You can integrate D3 and React in three common ways. Let D3 render the SVG and manage the DOM inside of an effect. Let React render the chart and use D3 only to draw the axes. Let React render everything and use D3 for scales and layout math. In this demo, I'm showing all three methods side by side. This one is using D3 driven rendering. This one is scoped D3 rendering. D3 is rendering only the axes. And this one is React owned rendering. This is where React is rendering everything. Now I can randomize the values and shuffle the order and watch how each one behaves. In this version, React renders a container. Inside useEffect, D3 selects that container and appends the SVG, the axis groups, and the bars. D3 owns that rendering. This maps directly to how most D3 examples are written, and that's why people use it. Common use cases are porting an existing D3 chart into React quickly, or teams that are already comfortable thinking in D3. Heavy D3 behaviors like simulations, transitions, and complex animations, and prototyping. It's pragmatic, but here's the trade-off. When React state updates, the component re-renders. If your effect is appending more to the DOM, you'll accumulate elements unless you manage the data join properly. Usually with D3's more modern join method, or you have to clean it up manually. So now you're responsible for reconciliation inside of React. D3 can absolutely handle updates correctly with join, but React is no longer the system reconciling that subtree. D3 is. It works, but React isn't the single source of truth for the DOM. You have two render systems touching the same tree, and that's the cost. This version narrows D3's responsibility. React renders the SVG, the bars, and the structure. D3 renders only the axes. We create group elements with refs, and inside an effect, we call axis left and axis bottom on those nodes. Why is this common? Because D3 axis generators are extremely convenient. They handle tick spacing, formatting, alignment, and baseline drawing. Rebuilding that manually can feel unnecessary. This approach gives you React ownership of the main rendering, D3 convenience for axes, and reduced lifecycle burden compared to the full D3 driven rendering. It's a practical middle ground, but the trade-off? You still have a small imperative island in your tree. It's controlled, but it's there. This pattern is especially useful when combining React with zoom, brush, force simulations, or certain D3 behaviors, where D3 needs controlled DOM access. Now this version keeps React fully in control. D3 is used only for scales, domains, tick calculation, and layout logic. React renders the SVG, the bars, the axes, and the grid lines. And why use this? Because it aligns completely with React's mental model. The benefits include predictable updates, easier shared state across components and charts, cleaner testing, fewer lifecycle surprises, and a clearer mental model. If you're building a real dashboard with coordinated charts, this tends to scale cleanly. The trade-off? You may write a little more code for axes, but the rendering model stays consistent. If you want more examples of the React-owned approach, the React Graph Gallery is a great resource. It's run by Yan Holtz, and it shows clean examples while letting React handle rendering. I've left a link down in the description. But here's the simple framing. If D3 owns rendering, you manage the reconciliation and the lifecycle. If D3 is scoped to a small DOM island, you limit that lifecycle tax. If React owns rendering and D3 provides the math, you maximize predictability. All three approaches are valid. Just don't mix them accidentally. Choose the one you need intentionally. That'll lead to a better development environment, and better charts, and better use of D3 overall. In the next video, we'll take the React-owned pattern and build a real dashboard with shared state. That's where the architectural differences really matter. The code for everything in this video today is linked below. Thanks for watching, and I'll catch you in the next one.